So next up, we have some Raspberry Pi equipment. You know, in the past, we've looked at using the Raspberry Pi, hooking it up to ADCs, DACs, and things like that. And we even hooked it up to one of the older PiFace digital control cards, which had a couple of relays on and a bunch of standard I/O and LEDs and inputs and things. So what I have here now, and these are already out of the box, is a PiFace digital Relay Plus. So it's not the 2, but it's the Relay Plus. This is the latest one that I got from Element 14, and it comes basically in 2 parts. This is the Relay Plus, which is the base board, and as you can see, well, yeah, no, maybe you can't see very well, but basically it comes with 4 relays and an expansion header. And if I just take this apart a second, I'll show you what that is. So that's the board there. It's got 4 relays down, these white ones down this side, and then it's got this little expansion header here, and a little also an additional dip header here that you can plug things into. All right, and then the second board that comes with this is a PiFace Relay Extra board. You can buy these separately. You can either get one of these, or you can actually buy a PiFace Motor Extra, which gives you a motor control card, part of an H-bridge controller basically on a card. Now unfortunately I haven't got one of those yet, so I can't show you it, but I have got the PiFace Relay Extra board, which is this one. See, and it gives you an additional 4 relays. So when you plug this onto the PiFace Relay Plus like that, now you've got 8 relays on one board that plugs into the Raspberry Pi. It's stackable, so you can plug another relay on top of this. All right. But the nice thing is you've got your 8 relays with the terminal strips. These they come with the standoff so that you can screw it down to your Raspberry Pi, so it gives it a nice firm base. I didn't quite plug that in right. There we go. But the other thing it's got is it still uses the 23S17 controller, which is a SPI bus to 16 I/O line controller, but you've used 8 of the outputs already for driving these using a ULN 2003 type buffer chip. The other 8 pins that are unused are actually on this header, which means that you can actually put a ribbon cable or something like that onto here and hook up to some other things. So you can have maybe your 8 relay outputs and have 8 inputs. So you can maybe take that through an opto-isolator board, or, you know, it doesn't even have to be opto-isolated, depends on what you're putting it on, but have a bunch of switches or something hooked up to there, and you've got quite a number of I/O pins now with one board. Before, with the previous PiFace digital boards, you had to, you know, you only had 2 relays on it, so you were a little bit limited. Now you can have up to 8 relays very, very quickly, and by changing the jumpers on here, you can put 3 of these boards on one Pi, and as I said, they can stack, which means that you can have these without having to have one of those like stacking riser things that aren't available for the PiFace 2 yet. They're only available for the Pi, the earlier versions pre-B with the 26-pin headers. So this is a great way of providing a bunch of I/O, and we're going to look at using this with the Pi. We'll fire it up under Linux just to show it working, but I also will update the program that I wrote for Windows 10 IoT that could drive the PiFace Digital 2 board, which is the one that had the 2 relays, and we'll modify it to talk to this one, to allow you to play with this one. The other thing that I want to look at doing as well with the Pi is you can run, you know, it's to see if we can hook it up to something like LabVIEW or something like that to make it more interesting. It will certainly be running under Windows 10. We should be able to talk to this quite easily as well and make some kind of useful application out of it. But either way, we're going to get it up and running, and I'll show you how it works and how easy it is to use. So that's the PiFace digital boards. Also, one of the things that has been very evident in the Windows 10 IoT space is the lack of a Wi-Fi card that's been supported by Windows 10 IoT on the Raspberry Pi. There was one, and it was the official Raspberry Pi Wi-Fi adapter, and could I get one for love nor money? No, but I finally managed to get one. I actually had to order it from the Pi Hut in the UK, and I managed to get one. It was only a few pounds plus shipping, so it was very reasonably priced. So I have this now. Haven't taken it out of the packet yet, but we'll give that a go with the Raspberry Pi. Now I have no doubt whatsoever it's going to work with the Raspberry Pi under Linux. I have a whole bunch of different Wi-Fi adapters, and they all work without an issue under Linux. But this is the reason I want this one, is because I want it to run under Windows 10, all right, on the Raspberry Pi. So theoretically I should be able to just plug this in and it will work. All right, obviously I'm going to have to give it the SSID and the password to hook up to my Wi-Fi, but this will allow us to do a lot more interesting projects by having it not tethered to an Ethernet port. So I look forward to that. So that's the next bit with the Raspberry Pi. Now, staying with the theme of Raspberry Pi, one of the other things that I have, which is really interesting, is I bought a Raspberry Pi 7-inch touchscreen. This is the official Raspberry Pi display. I know it's been out for a little while now, and I'm a little bit slow in getting to do a video on this, but I wanted to get this all nice and up and running with Windows 10 IoT. You know, out of the box, this will quite happily work with the Raspberry Pi and Linux, like Noobs and things like that. But I wanted to get more of interest was using touch capability under Windows 10 IoT. And I have it sort of all working. I've got it all working with the graphics display under Windows 10 natively, so you don't have to do anything special to make that work for Windows 10. And I do have the touchscreen working, and I actually have it working with a full 5-finger touch. You can do 1, 2, 3, 4, or 5 fingers, and the data, the XY coordinates for all of those touches are available to the application. Now, I've only written a rudimentary interface to get that right now. I found that I couldn't get the interrupt working that came out of the controller on the Wi-Fi display to the Raspberry Pi, so I have to poll it, which is a little unfortunate. But nevertheless, I do have it working, so I will show you that operationally. I'll show you how to install it, how to get it working, and what you can do from an application perspective. Now, I will do a quick install for Linux under Noobs, for the latest Noobs and everything else, because there's been a lot of versions since the last half-hour install video that I did for that. And then I will do a complete separate video for installing Windows 10, the very latest one, because there's been a new one come out recently for the Raspberry Pi, and there's it's a lot nicer now than what it was before, and there's a few new features. So I'm going to go back and look at some of the previous videos I did for driving displays. It won't count for this one because this one's being driven by the core hardware of the Raspberry Pi, so it's already fast and performant. But for the other displays that I've used with it, where I've had a a smaller 320 by 480 display or something like that with touch, where it proved to be very, very slow on the SPI bus, the latest Windows 10 IoT software that's come out is supposed to be 100 times faster for the SPI interface and the I2C and things like that, and GPIO. So we will investigate to see whether that is actually true. Anyway, so Raspberry Pi, 7-inch display, much faster I/O capabilities, etc., etc. I look forward to playing with that. Now, the next thing I've got for the Raspberry Pi isn't strictly Raspberry Pi, but it is competitors to the Raspberry Pi. And I've got two other boards here. This one is a Rose Apple Pi. It's from the Rose Apple Pi team in Taiwan, and they sent me this to have a look at. And one of the nice things about this board, I'm just pulling it out of the wrapper. I had already unwrapped it, but I put it away when I was done, and then I realized I had not recorded the sound. Is this board is I think using a similar processor, obviously, but it has 2 gigs of RAM, and it has a USB 3 interface on the board as well, not just USB 2 but a full USB 3. And I think because of that it also has a gigabit Ethernet, but I'd have to verify that when we go in and have a closer look. So you can see here, this is the board. All right, it's pretty much looks very similar to the Raspberry Pi. Only difference is you've got 2 USB 2s, you've got a USB 3, and you've got your Ethernet, which I think is gigabit Ethernet. You've got your core controller, and then you've got your you've got your camera interface, you've got your LCD interface, you've got your HDMI output, which and then you've got your audio out with probably composite video on here. What you've also got is a TTL debug port. RS-232 kind of serial protocol port. It's not RS-232, it's TTL, but nevertheless you've got one of those. You've got your standard little micro USB, mini USB connector for power, and you've also got another little connector here, which I can't remember what it's for, but we'll go into that when we start investigating. And then lastly, on the bottom, you've got your micro SD slot for your SD. Now the other thing you got on here is a couple of reset buttons for various function. One I think is for resetting the CPU, and I think the other one is for simply turning the power on or off using a button. But again, we will investigate that more when the time comes. So I'm going to do a lineup with the Raspberry Pi, the Rose Apple Pi, and another one that I'm just about to tell you about that I have. I'll also connect the Raspberry Pi LCD screen to this and see if it actually works with it as well. So that's the Rose Apple Pi. Now the last Pi-based products I have here is and now these are in a banana. This is in a Banana Pi box, but it's a LeeMaker guitar, which is another Raspberry Pi competitor, but it's more like the Raspberry Pi compute module in that its actual processor is on a little plug-in board, and if I show you this, you can see. So this is very, very much like a Raspberry Pi. I think it's the one we call the A now, where you've got the compute module stuck on a motherboard that provides all the I/O. And what we've got here is, I think it's got at least a gig of RAM. It might be more. I'd have to double check. You've got your LCD and you've got your camera interfaces here. You've got HDMI output. You've got 4 USB 2 outputs. You also have a full USB 3 interface here and the SD card slot. Now what you've also got on the other side is you've got your Ethernet adapter, which I also believe is a gigabit as well, but I'll have to verify that. But the other thing that's actually built right onto this is a Wi-Fi adapter. It's actually built right onto the board, which is really cool. You also have infrared port and a standard barrel jack for power, which is kind of nice. And then you've got a TTL debug COM port for power-up diagnostics and various other things. And you've got your standard 40-pin header, which I think both this one and the previous board that I was looking at, the Rose Apple Pi, you can also update the DFU and things like that on those. So that's really, really cool, and it's got the SD card slot as well, of course. Is there anything else on the back? Nope, there's nothing else on the back. I mean, there's a bunch of components on the back of this, but nothing else of note that we need to talk about. So again, a couple of switches for controlling the board. Actually, this one has 3, one here, and one here. It's got a microphone built onto the board as well, although if you put this into a case, it probably isn't going to be too useful, but there is one there anyway, and you've got your composite video out with probably audio out as well through that connector. So a very capable board. It's the LeeMaker Guitar Pro board, and I look forward to putting this up as well. Now what came with this board though, which is really, really nice, and you know, one of the things, if you've been following along on my YouTube channel, is I do a lot of industrial control, is that I've been looking for a display that I can use as an HMI display for my CNC machine / other motion control boards that I put together. And what came with this if I can get into it. So what came with this is a 7-inch LCD display, which when you look at it is very, very similar to the official Raspberry Pi display. You've got a little controller on the back. I don't think you can mount the other board onto this, although it does have threaded inserts on here, so it might be possible. They look like they're threaded. It might be possible to mount it on here, but you basically got your LCD interface, you've got your main display, you've got your interface controller and things like that on here. You've got your touch controller down there, which looks like it's the 8051 base controller, the same as the Raspberry Pi controller has. And we'll talk more about that when we start looking at the Raspberry Pi display. It's very interesting what they have on the display. So we will hook this up to the LeeMaker guitar and see how well this works. And as I say, this, between the LeeMaker guitar and this, and the Raspberry Pi 2 with its 7-inch display, it's going to be quite interesting to see how these two things compare. Certainly spec for spec, they're very, very similar. Except for the fact that you get a lot more on the LeeMaker guitar board, because you've got the Wi-Fi integrated, the infrared, and a whole bunch of other things already on the board there. So that's the Raspberry Pi. I think all the parts for the Raspberry Pi there that we've got to look at over the next little while. So now we're going to move on to something else. So So a lot of people, I've been, because I actually subscribe to a few other forums as well, and YouTube channels like Dave Jones' EEV blog and stuff like that. And a few of them have been using this SJCam Sports HD DV SJ4000 camera. And I looked into it, and they're actually very, very inexpensive. The one I got would cost about $80 odd if you buy it from eBay or some various other sources. It varies between a little bit less than 80 and a little bit over $100, depending on where you buy it from and what extras are thrown in with it. The one I got came with 2 batteries. It comes with so many connectors for handlebars, helmets, belt clips, and God knows what, that you wonder why why you'd need so many options. It also, when you look at the website, it talks about the fact that you can get them in all sorts of different colors. Well, this one came with every single color faceplate that they advertise, so you don't have to worry about what color you're going to buy, because you get them all and you can easily replace them. You've got handlebar clips, you've got belt clips, you've got wrist straps, you've got dashboard sticky pads and things for it, and all sorts of stuff. You get a power adapter for it so that you can charge up the battery, and you get the actual let me just put this down. You get the actual camera. Comes in a really nice, fairly rugged waterproof container. All right, this will go down to apparently 30 meters in depth, so we will test that. Let's say, I don't know if I'll take it down to 30 meters, but I'll certainly throw it in a bucket of water. And inside the camera, I just clipped it out of there. We'll do a full review or a closer look at this at some point. That's the actual SJ4000 camera. It's quite tiny. It's a few inches by a couple of inches by about an inch or so. It will take 12 megapixel pictures. It'll do full 1080p video. I think only 30 frames a second though. And it's got a little display on the back, which you can see there. It's not huge, but it's big enough to see what you're doing. And you can flip through there's a taking video, now it's flipped to doing still pictures, and you've got a review pictures, and then you've got a menu where you can actually go through and look at all sorts of things that you can change, the settings, the resolution, TV out mode, video capture, time lapse, and things like that. And one of the things I wanted this for is to be able to set it up somewhere. It's got a very wide angle of view. It's got a digital zoom, not an optical zoom. So I'll do all my digital zooming and post-processing with my video editor. But one of the things that this has is the ability to set it up and tell it to continuously take pictures at a certain time interval. It's not just press the button 10 seconds later or 30 seconds later it takes a single picture, or you press the button and it takes 20 or 30 pictures and stops. You can actually set this up to continually, every selectable time period from a second or a few seconds up to I think as many as 30 minutes between shots, and just keep going until the battery runs out or it runs out of SD-ROM space, SD card space. So, and if you have it plugged into a power brick feeding into the USB, then it's not going to run out of battery power. So basically, if you threw in a 32 gigabyte SD card, you can run this thing for probably several days, taking loads and loads of pictures, and then bring them into your video editing software, chain them all together and make a time-lapse video. So maybe 6-7 hours worth of video could be reviewed in 3, 4, 5 minutes or something like that, depending on how much you want to compress it and how many pictures a minute, or what time interval between the pictures you set up. And that's going to be great, because I've had a lot of people asking me about doing videos for my CNC router or for the 3D printer and things while it's operating, so they could see how it does things. And I figured that, with the 3D printer, some of the prints that I've done recently have taken over 24 hours to print. And I don't think anybody wants to sit there for 24 hours and watch a 3D printer do 3D printing. But if that can be speeded up to, like 5 minutes, 10 minutes, then that's doable. With the CNC router, of course, it's things happen much, much quicker. You would be, maybe a few hours at very, very most for a complex thing you're cutting out, the fairly large one. But for a smaller one, it might be a lot quicker. But either way, by putting it into the waterproof, dustproof housing, I can put it fairly close to the cutting head, or even attach it to the cutting head. Well, to the spindle anyway, not the actual cutting head. That would be kind of silly. and have it video close up the whole thing as it's going. So that will be kind of interesting thing to try out and let you see what it does. So anyway, I know that a lot of people seem to have negative feelings about these SJCam sports DVD camcorders, especially people that like the GoPro kind of displays and things, and they're not in the same ballpark. You know, the GoPros have their space, and these things are at the lower end of the market. They've got some niche functionality that they can do, which for me is good enough. You know, they don't have any optical zoom. It does have Wi-Fi on it, which is nice. But you know, please don't start spamming just because I've got one of these. It's for a specific purpose, and it's going to be useful for my lab and for the CNC and various other things for doing some time-lapse photography, and that's really what I've got it for. Anyway, so we'll see how well that works out as we go through. That's the SJCam 4000 camcorder, well, camera. Okay, the next item I've got has just recently arrived, and I think you're going to find it very interesting, especially the people amongst my viewers that are interested in test and measurement. Sorry for the messed up box slightly there, but what I have here is a Red Pitaya. It is the debug kit, which means it's got a few extra things in from the standard kit. And they've also sent me a few sensors to go with it. And what this is if you've seen the little, you know, I've actually got one that I'm going to build up, and I'm actually going to probably build it up before I do the review for this, so we can actually put them side by side. I have a little kit that I got sent to me from GearBest, which is an oscilloscope. It probably costs about $20–25 to buy. And you build it up. It's got a little 2.4-inch LCD display, and it has a very rudimentary oscilloscope. And I haven't built it yet and tested it yet, but from everything I've seen, you know, if you've got a student or somebody or a young person that's just dealing with Arduinos and wants to measure a few signals and see what they're doing at some relatively low frequency, then, you know, one of those little LCD kind of $20–30 kits might do the job. But if you look behind me, what I have here is I've got an oscilloscope up here, which is an A10 1102 CAL, which is a 2-channel 100 megahertz oscilloscope, and it's barely 100 megahertz. I think it's probably more like a 50. It's basically, you know, an eBay special that I bought for a few $100s. And you know, it's an oscilloscope. It's not anything else. It doesn't do anything else. And I've also got a Tektronix MDO 3054 here. Now this one has an arbitrary function generator, it has a spectrum analyzer, it's got 4 channels of analog inputs, it's got 16 channels of logic input, it's got an arbitrary waveform generator built in, it's got protocol analysis and all sorts of things, and a nice big 10-inch-ish display. It's a really, really nice oscilloscope. Now the problem is that well, it's okay, but it's still not cheap, and it does one thing. This is really, really nice, and it does a huge amount of things, but it's horrendously expensive. So the average student and hobbyist probably wouldn't be able to afford one of those. All right, I mean, and if you look at this, I've got, you know, you've got a function generator, you've got a DMM, you've got an oscilloscope, and these 3 things together, you know, they add up to, you know, quite a bit of money. So what do you do if you want something better than one of these little $20–30 devices that does a little bit more than DMM or other things, but you don't want to be paying thousands of dollars for it? Well, what I have here in the Red Pitaya might just be the answer for what you want. Now I'm going to do it, as I say, I'm going to do a full review for this. Let me just try and put this down so I don't drop it everywhere. But basically, the Red Pitaya is a credit card sized board that is remarkably powerful, and one of the reasons for that is it has an ARM Cortex processor coupled with a high performance FPGA. Now I don't have all the specs available right now to hand, but I will deal with it when we go to it. And you can see there are 4 SMA connectors on the end of this thing. It's got Ethernet, it's got a USB interface, it's got a SD card socket, it's got 2 USB micro USBs on the bottom, it's got 2 SATA interfaces, so you could plug in things like a hard drive and things to it. It has a boatload of I/O pins on both sides of this board. You've got your main FPGA and processor under here, and then you've got your analog outputs. You've got two high-performance analog outputs, and you've got two high-performance, these are the outputs, and you've got two high-performance analog inputs. And what this is able to do with the right software is it can be a 50 megahertz fairly high-performance oscilloscope, 2-channel. It also has software to run as a spectrum analyzer. It can also act as a function generator. And it also, with those digital I/O lines, can act for reading in and out and controlling other things like relays and sensors and various other things that have a digital I/O. But basically, if you think about the size of that and the fact that it's, I think, 200-300 euros, it gives you a lot of functionality in a small package. Now, you can't go and put, hundreds of volts into it like you can with a DMM. It's designed for lower voltage measurement. It gives you a 20-volt input, which for 99% of what I do and what other people will do is probably way more than enough, because most of us are working with circuits that are only working 3.3 volts, 5 volts, and things like that. I think with my power supply system, you wouldn't be able to necessarily hook that up. Maybe if you AC coupled it, it would be okay for looking at noise, but not DC. But anyway, we're getting more about the specs of what it can do. But it's a Red Pitaya, and the kit I have is the debug kit. And what it comes with, it comes with a pair of oscilloscope probes, 50 megahertz oscilloscope probes, a USB lead for hooking it up to your computer. It comes with an 4 gigabyte SD card. It comes with a couple of SMA connectors. It comes with a universal power adapter. Now, this is the kind of adapter where you have your basic transformer brick, switch mode power supply in it and things like that. This one looks like it actually comes from RS Components. And then you just drop in an adapter that suits your country of use, whether it be a 3-pin UK plug, a 3-pin or a 2-pin USA North American plug, or a little angled Europe plug, or one for Australia and things. You get a whole bunch of different little adapters here, which will allow you to use it in all sorts of different places, which is really, really nice and quite thoughtful. And they just clip in. The ones you don't use, of course, you can just put away in a drawer. The other things that they sent me to go with this is and this is not part of the debug kit. You can actually buy this as a separate kit. Now, they didn't send me the entire separate kit. They just sent me a few pieces to play with. Is actually a Seed Studio set of sensors. What they've done is they've designed a board that will plug straight into the top of the Red Pitaya, that will allow all those connectors in the middle to plug into these various sensors and things. So what they've sent me from a sensor perspective is a temperature sensor, a small PIR motion sensor, a LED output, and a buzzer. So those are 4 little sensors. Now, I'm sure I'm going to be hooking up a whole bunch of other things as well that I have of my own already. But the other thing that is on here, which makes it really, really nice, is it's also got an Arduino compatible header. So if you've got some Arduino boards, then technically you should be able to hook them up to this as well and drive those too, which will be interesting to have a look at and see what we can do with that. So that is the Red Pitaya. I'm really, really looking forward to playing with this. And like I say, I'm actually going to do kind of like a head-to-head thing where we power up my little A10 oscilloscope, which claims to be 100 megahertz. Use the MDO 3000 as the reference oscilloscope, and I'll also have the little $20-$30 oscilloscope, which I don't have high expectations for, but it'll be interesting to do a comparison. And then I've got my Tektronix Agilent 33622 arbitrary waveform generator that I will we'll set up some frequencies within the range that Red Pitaya can do as well, and see how they compare. Because the Red Pitaya has 14-bit analog to digital and digital to analog converters on it, then I have high expectations, because even my Agilent arbitrary waveform generator is not 14-bit. I think it's only 12-bit resolution. So you should have some pretty good signal to noise ratio, low noise kind of outputs capability from the Red Pitaya for doing audio performance checking and stuff like that. Now, some of the other things that it's capable of, and I don't have the adapter yet, they don't have them available yet, but I can still do it with this, just not quite as accurately or as conveniently, is they have some software to run it as an LCR meter. So we will have a look at that. So one of the things that is always lacking in a lot of labs, a lot of digital multimeters, they come with a capacitance meter, but they can't measure an inductor, as an example. Now I have a little, it's up here somewhere, here we go. This is a little component tester that I got from eBay. It costs, I don't know, $20, $30 or something, component tester. It'll do inductance, capacitance, transistors, FETs, all that kind of stuff. So it'll be interesting to see what this reads and compare it to my Agilent handheld DMMs for capacitance and what the Red Pitaya does. So there's a lot of capability for these. And the other thing about the Red Pitaya that's very, very interesting is that it has multiple programming options. And going to the simplest mode, it actually uses Sketch, which is this little graphic. You drag blocks onto a little programming screen and everything else, and you can download it into the board and run your applications using a simple Sketch type environment. Now, anybody that's been using an Arduino using Sketch or one of the little microbit controllers and things like that will be very familiar with that interface, and so being able to drive one of these should be a relatively straightforward thing. But you can also program it in C and various other languages and script to it. They have LabVIEW and MATLAB interfaces available for it as well. And the other nice thing is that if even if you don't leverage right away the FPGA, once you get more advanced programming with the Red Pitaya, then you have this extremely powerful capability by writing code that will actually be compiled into the FPGA compatible code, which means it's going to run at native hardware speeds instead of software speeds. So I look forward to investigating a whole bunch of those things and seeing how well this is going to work. Now, this is also version 2 of the Red Pitaya. They came out with one a little over a year ago, which has been available, and this is now the next iteration of it. So we should be able to see a lot more capability, a lot more applications being available and things like that. So again, I'll provide the link in the post with this that shows you the Red Pitaya's, you can go there and have a look at what the Red Pitaya can do and things. But anyway, that's pretty much everything I've got right now for electronic side of things. Now the next thing I want to look at, which has a little bit of electronics in, is something more about the CNC side of things. So let's go have a look at that.